time. Before we start, today we are going to hopefully finish the conceptual modeling. That is ER modeling, and will be followed by the GCP lab. On the GCP lab, I'm going to briefly introduce what is the Google Cloud Computing Platform, and we will activate the $50 the coupon that you can use throughout the semester. However, if you never use the GCP, the free trial, each Gmail account allows the $300 the free coupon, so you can use both of them. Because I realized the last semester, sometimes some of the students need more than the $50 to finish the semester. In that case, I'm going to add the additional coupon to the Google, but you can use also $300 the free trial. The most important thing is you need to understand how the cloud computing, your usage of the computing power. If you understand such the user and the billing account and so on, so you are able to use the GCP. Then please submit your handwritten homework that I asked in the class last week before you leave. Okay. And I'm going to briefly also introduce what you guys need to do, which is due on the project page 1, which is due on tomorrow, but it's allowed, always allowed without penalty. You can still submit by the end of the weekend, okay? But after the weekend, there's no way to submit. Okay, so using the handout that we have used, we are going to continue. So for your review, so we are going to quickly review the ER diagram for the company database. So first thing that we need to do is find the entity. So entity is sometimes, actually what we are going to find is the entity type among the bunch of entities. Think about the object-oriented programming or the object-oriented modeling. So first thing, when you design the class, before you design the class, you need to find the number of objects in your real life. So student object, another student object, another student object. By combining all the student objects, you can decide what information you are going to manage. Like the data variable, then the number of the operation, the method. Okay, it's very similar. So from the number of entity, and then we can decide the entity type. So for example, in the company database, we identify the 4 entity type. First, the department, and employee, and also we identify the project, and also the dependent. And to simplify our design, we are going to use the diagram. So that is the EI diagram actually. So for the entity type, we are going to use such a rectangle, like this, and like this. And after we identify the entity type, so to describe each entity, so we can find the number of attributes. So for example, for the department, so we have the name and the number and manager information. And so I'm not going to write all of them to save the time. Then we can use the over to represent each attribute and connect to the associated entity type. Among them, we can identify the key attribute if that is unique. So in other words, using that attribute, if we can identify the specific entity or the data, so that can be the key attribute. Key attribute can be underlined. Similarly, we can identify the employee for the attribute for the employee. We are going to add the name, which is not here, social security number, and address, and then also salary, and also we have the sex here, and the DOB. So similar, just like the department, so we can identify the key attribute here. So that is the employee, and also for the project, we have the unique name, and also number, and then the location. We have the location for the department here, but in case it's a multi-value, so not just one location of the department, sometimes it can have the multiple location. If you read the description carefully, it has the number of the several locations. In that case, we are going to use the double, the over to identify the multi-value, the column, multi-value attribute. Later, we will see why we specify such the multi-value. So that is the limitation of the relational model later. But in general ER modeling, you don't have to. If you are not going to design the relational database, actually you don't have to identify the multi-valued one. But only in case of the relational database model, so during the conceptual modeling, we need to identify them. Okay, then for the dependent, we have the name, and the sex, and the DOB, and the relationship. In this case, this is a key, so which means sometimes entity can have the multiple, several, the key attribute. It doesn't matter. If those who knows a little bit about the relational database, each table has the key attribute, which is called the primary key. But this is not the database design. This is just a conceptual design. It doesn't matter whether we have the 1 or the 2, 3, so as many the key attributes you can identify. However, sometimes we do not have the key, for example, dependent. Using the name, we can identify the specific dependent. It may be possible the same name of the dependent in one company. So, but we may use such a name for the key if we can identify who is the employee of that. So at the time, if that may be used in future as a key, so this is called the partial key. In case of partial key, we can represent the dot line. Okay, so then this is the entity, to identify the entity and their attribute. So next thing is we are going to identify the relationship. So that is the reason this is called the ER modeling, and it's mostly used for the conceptual design. As you realize, it's very simple. If you know the data and the domain, it's not very complicated. However, sometimes the most difficult thing is without understanding of your data, like your customer gave just a bunch of files. Then you do not know what's the meaning of this number and this number, it will be hard, much harder to identify this. But the company is a general description mostly, so you know how the company is organized, who is the employee, what is the department. So because of that, it's simple. But in this example, you are going to familiar with the notation and how we can identify such a thing. So then, next thing is a relationship. So if you take a look at the example, it's actually the italic, the represent. For the convenience is italic, use for such a relationship. One is the manager. So first, during the entity type, we use the manager information as the attribute of this one. But if you read the description, who manage the department, employee manage the department. So sometimes the two entity types are involved to represent the information. So because it's kind of the one thing you need to keep in mind is in the database design and conceptual design, physical level design, and the management. The most important thing in the database management or administration or the implementation and development, most important thing is the non-redundant information. If you have the redundant information, it will be very, very complicated. And also it takes time. Okay? So think about if your information is in the payroll office, and also department, the manage your information separately. And also the registrar office, the manage your information, student information separately. So like for each department manage the student information separately. Then what happens? When you change your information, like you move in the new apartment, then you need to inform to all of the database. So it will take a time. Also, it's not consistent. Somebody update, somebody not. Then later, you have all the information in some of the databases. So it's also when you search whether the students are the same or not, it will be complicated. So database, most of the data, especially relational database, really hate and avoid any redundant information. For example, here, if we manage the manager information as the department as an attribute, but this manager is actually employed, right? So it's a duplicate, redundant information, redundant design. Instead, we try to create such a relationship between them. So that is the manage. Like this, using the diamond shape to represent the relationship. Okay, so relationship involve the two at the entity type. Later we will see it may be possible 3 entity, 4 entity, but mostly the 2 entity type will be involved for the one relationship. Okay, then we have another relationship here. So this is a work for like this. After we identify the relationship, the next step is we need to decide 2 things. One is cardinality. Cardinality means type of relationship. Like if you think about the math class in the elementary school, so one-to-one mapping or one-to-many mapping, many-to-many mapping. It's exactly the same thing. So for example, many employees works for one department, right? Also, the one department has many employees. So this is the many-to-one relationship. Similarly, the manager, how many manager? One manager. In this case, is the general case. It's not actually the specified whether I can manage the multiple department, but just the consider general case. One employee manage one department, and also one department has one manager. So it's a 1-to-1 mapping. Okay. However, in case it's specifically mentioned that the one employee manages the multiple department, it will be 1-to-many. Okay? So you need to decide such a thing. That will be important, the constraint concept in database design later. And also another thing is a participant, means whether it's optional or mandatory. For example, each department must have the one manager, which means it's a full participation or the mandatory participation to this one, the relationship. So at that time we can use the double line. Okay. However, from the employee point of view, not all employees are managers, so it will be optional. So in terms of the set theory, it will be like this one. Okay, this is not match. Okay, from the A employee point of view, it's optional, but for the B set B point of view, is the all element has the mapping. So it's the compulsory, it's the mandatory. So we can use a double line. Sometimes it's not clear whether this is the notation actually is not very clear. Sometimes, for example, employee. So whether employee, there might be employee like the new employee who are not assigned any department. At that time, it may be optional. Also, department, we just create the But because of manager, it may be definitely like this one, mandatory. Because of manager. Manager is also member of the department, like this. We can decide such a full or partial. So you should be careful. If that is clear, then we can use the double line. Okay, then we have the department control the number of the project. How many projects? The many projects is clearly mentioned. So one department manages the number of projects. And also, what else? The employee works on the project. So when we work on the project, how many projects? Number of projects. I'm going to work on the project A, 10 hours. Project B, 20 hours. Project C, the 10 hours. Also, from the project point of view, how many employees? Many employees, which means this is the many-to-many project. At that time, if you read the description carefully, the database will manage what? Number of hours. Then, number of hours is the attribute of the employee. Because the employee may work the multiple project. So, number of hours is here, attribute of the project. It's it hold the employee. So, at that time, we can create the hours attribute for the relationship. So this is the case. So in case many-to-many, the relationship, we are not sure whether this is this one. So it's many-to-many. So we can consider the attribute of such a mapping as the attribute of the relationship. Okay? Somebody may be curious. What about this one? One-to-one, one-to-many, can they have the attribute? Like for example, start date. Where is the start date? It may be possible start date here. Okay? May be possible. However, this is the one mapping, one-side mapping. So it doesn't matter whether this start date is here or here. Okay? So it's up to you, but for easy understanding, this will be the better. Okay? It depends on. It's not wrong, but it may be better. So most of case of the many-to-many, so has the attribute, but in case of one-to-one or one-to-many, so you can decide the one side, the attribute entity as the entity that can have the attribute. Okay, so that we have the has one, two, the many dependent. Last time I missed one of them, that is the employee. So if you take read the employee information, the third bullet, we keep track of the director, supervisor of each employee, which means we supervise the James, and also we supervise the Patel, and the Patel supervise Smith. Like this one, it's a relationship. So supervise relationship for which entity? Employee, supervise, employee. How many entity type are involved? One, two. It's basically two employees, but they are the same, right? This one used for what? Supervisor. Okay, supervisor. This one is used for supervising. Okay, so at this time we can just consider this is the two entities, the relationship. But when we represent, actually they are the same entity, so supervise. Like this one. Then that makes sense. So at that time, what is a cardinality? One-to-one, one-to-many, many-to-many? One-to-one. So which means I can supervise only one. I can supervise the many, the employee. So many side. Then how many supervisors can have in this case, one supervisor. So one to many, which means this side is a supervisor. The meaning of this side is the supervisor. This is the supervising. Okay. So then we can have the one to many relationship. Okay. Then any missing. So pretty much I covered the most of that. Okay. Then except the weak entity. So last one is that if you see the last one, not last one, the number 4, weak entity type. So last time I introduced there are 2 types of entity. If you can find such a key attribute, we are going to regard such an entity as just the normal, the entity. Eventually later, it will be table, database. Okay? Automatically. You can also imagine. So this will be table, table, table. But this does not have the key attribute. It has only partial. So at that time, this kind of the entity is considered as the weak entity. So weak entity does not have the key attribute. Okay, then we use the double rectangular. So in case, so eventually later we need the key attribute to identify. Without the key, it's always the full table scan, linear search, brute force, which is not acceptable in the database because it's slow. So we need to find something key. So think about how you can identify the specific dependent in this database. Name plus who is your employee, right? So it may not possible, it may be possible the both parents side, mom and dad are here, but to simplify the problem, just one employee. So if you can identify the employee plus name, then we can identify the specific, the dependent. So at this time, such a relationship to identify the entity of the weak entity, we are going to use this relationship. So this relationship is called identifying the relationship. So identifying relationship plus weak entity and identifying relationship are work together. So when we have, it doesn't make sense if you have only the separate, the entity, weak entity, which does not have the weak entity, there might be something wrong, the problem on your design. Okay? Because the idea of such an EI diagram is we are going to find such things, the entity and their relationship. They are connected. If not connected, like I have another entity which is not related, this means it's a different database. Okay? So probably you can find such a identifying relationship if this is a part of your database. So this is called identifying relationship. We use the double, the diamond, and this should be mandatory. Otherwise, it doesn't make sense if there is just a dependent without employee. It doesn't make sense. It's automatically the double, full participation. So this is called the weak entity. So in your design, most of case, so many of the case, not most of the, many of the case, you may not have the weak entity because intentionally create a dependent ID, for example. Okay? Instead, or a social security number we can use. At the time, it has a key, so it's not the weak entity. Okay? But from this, it will be, if we do not have such a relationship, if you miss it, then it will be isolated, the entity. So it will be separate the database, like another dependent database. So in most of cases in the real life system, the design, so you may not see a lot of weak entity because automatically the creator find the key attribute. But for your practice in your database design, conceptual design in your phase 1, please make the intentionally to find the weak entity and create the identifying relationship. Then later we will address such a problem to create the database design later. Okay, so this is a weak entity. So it's mostly done, except I think you will see some number of the employees, like this one, using the dot over this. This is called, it's not used a lot. Actually, the database design itself, we don't need. It's not mentioned here. But do you remember our database design is a two-part. The conceptual and the physical database design and functional analysis, application design. So from time to time, we will take a look at such a functional, the application design. Okay? So, for example, when I take a look at the functional, the application, the requirement, many of the time we retrieve number of employees for each department. Okay, even though that is not mentioned in the database description, but you realize, you find such the functional, the requirement. Then at the time, is that we can calculate every time the number of employees, right? Instead, why don't we keep the number of the employee attribute to save the time? So this is called the derived attribute. Derived, okay? It is not the description of this one, but you can calculate from the existing database design. Okay, so at that time you can add the integer. If that is a critical, you believe as a designer, so you can create, you can add the attribute for the number of employees. But from time to time, or sometimes real time, you need to keep update this information. So you should be careful. If this database is changed a lot, it will be a problem. But if this information is like once a year or 10 years, so maybe possible. Then you can periodically update this one. There is a solution to address this kind of issues. So like the materialized view, I will introduce much later, like the week 8, 9, before or after the midterm exam, and so on. Okay, so this is the final output of the company database that we use as a first example of the ER modeling. Any questions? So, best understanding the ER modeling, the conceptual design itself is not very complicated. It's very simple. Even though you don't take the lecture, most of you, I believe, that because you are so smart, so you understand this one. Think about when you already organize your room. Nobody wants to separate the material, the database material is sometimes here, sometimes other, or you mix the operating system and the database together. No, nobody wants. You can collect the same material in your file and another material in your file, because also if they are in the UB, the courses, so you will put such a UB course material on your desk, or something related information, you can collect that together. Okay, that's the idea of the ER modeling. It's a conceptual level design. So this one used a lot in our real life, specifically the data and the database modeling. Even the UML modeling, object-oriented modeling, are based on this ER concept, ER modeling. So ER modeling is the most popular and mostly used the conceptual level design in the real life project. Okay, so this is a conceptual level modeling. So ER, as the name implies, the entity and the relationship modeling. Okay, if there is no other question, so why don't you take a look at the handout 1, 2, 3, page 4. If you take a look at the page 4, it's slightly different from this one. So this one is different from the page 4. For example, the employee, the name. The name is just a normal attribute, but it can be the composite attribute. If you believe that we need to specify the component of each attribute, we can use such a tree, like the structure. So like the first name, middle name, initial, last name. Address can be. Then, is there any general rule to decide whether this is a composite attribute or the normal attribute? It's a case by case. You need to decide by analyzing the customer requirement or project description or your database description, or sometimes functional analysis. Think about when you take a look at the function of each application, most of the time this is a string name and this is a CD name and this is a state name and the zip code separately, which means you do better to store them like this way. However, if your most of the application of that use the address, it's just address, full address, one text box, then is the single, and not this one. There's the address here. So one attribute may be bad. So it's up to you. That is the reason there is no general solution most of the time. It's the case, it depends on the requirement. Because of that, sometimes it's very hard to grade your midterm and homework. Because if you argue really, so I tried my best for general case, okay, not the ambiguous thing. So in case you have the assumption, please state on your answer or on your homework, even your project, okay. So that will be the ELA. Also, another different thing is the notation of the cardinality. For example, the department, and employee. The employee and department manager. This is a one-to-one, okay? However, if you take a look at the example of the cardinality in page 4, this is 0, 1, and this one is the 1, 1. If you want to specify more details, for example, in case of 1, 1, and 1, 1 means it's just to represent one-to-one mapping. Okay? Even though you have the double line here, but this one is mandatory. So sometimes you want to clarify what is the minimum value for the participation. What is the maximum of the participation? We can use such a notation. So when we represent such a more details of the cardinality on the relationship, it's a minimum number of entities to that participate in the relationship. This is the maximum. So min and max. For example, be careful, it's the opposite. When we are saying the one-to-one mapping, one employee, the manage the one department. But this one, the employee, okay? Employee can manage minimum 0 department. Most of the employees are not manager, right? And maximum 1 department in case manager manage the 1 department. So this is a min-max notation that describes number of the disk for each entity. So for example,